Hello everyone, this is Mr. Butler Maths, and in this video we are looking at adding fractions. I'm going to start with a few simple examples and then build up to increasingly complex examples. Throughout the whole process I'll be trying to make this as visual as possible, and I hope you find this video useful. Okay, so my first example, I'm going to start with 1/4. So I've split this left hand square into quarters, and to represent 1/4 I'm going to shade in one of those quarters. I know it's a quarter because there are 4 boxes and one of those is shaded in, so this is 1/4. I'm going to add to that another quarter. I've shaded this one in a different colour so it's clear that it's different, but this is again 1/4. One out of those 4 squares is shaded in. And now if we add those together, I've got my blue square and my yellow square, my blue quarter and my yellow quarter, and in total there I have 2 quarters. The denominator is the same because it's still quarters. There are still 4 boxes there, but now I have 2 shaded in, a blue one and a yellow one, so that's 2 quarters. Also notice that those top 2 quarters together make 1/2. 2 quarters is equivalent to 1/2. I'm not going to go too much into equivalent fractions, but that's just a little reminder. 2 quarters is equivalent to 1/2 because half of the square was shaded in when we shaded in 2 quarters. Now let's move on to another question. Let's move on to another question now. This time we are looking at eighths. So I'm going to put my 3 shapes in to start with, and I'm going to break this one into 8 different squares. My left hand one I've broken into 8 different squares because we're looking at eighths. Okay, I'm going to shade in 3 of those. So that's 3/8. 3 of the 8 possible squares are shaded in, and I'm going to colour that blue. Okay, my next box, I'm going to shade in 4/8. Okay, 4/8. I've shaded in 4 out of 8 possible squares in that shape. So that's 4/8. Okay. And I want to add them together again. So let me just put all the squares that I've got together. Those 3 blue squares are from the first one, and those 4 yellow ones are from the second one. And if we put them all together, we can see that only one of them isn't shaded in. And if I count them up, there's going to be 7 squares that are shaded in. 7 out of 8 possible squares. Therefore, that is 7/8. Okay, so we've started quite simple so far. All of our shapes have had the same denominator. They've had the same number of squares. Now we're going to look at the case where they've got a different number of squares. And I've got 2 examples where we cover shapes which have a different number of squares, and I'm going to talk through how we deal with that. Again, I'm going to put in my 3 empty boxes to start with. The first one is going to be 8s again. In fact, why don't we just leave it as 3/8? So we're going to start with 3/8. Okay, that's 3/8 because 3 out of 8 possible squares are shaded in. For this next one, I'm going to split it into 4. Okay, so that's going to be quarters. Each possible one is a quarter because the shape has been split into 4. So the denominator of the fraction is 4, so it is a quarter. I'm going to shade in, I'll just shade in 1/4, and I've shaded that in yellow. Now, you might think, because of what we've done before, that I can just add everything together. So then that would be 3 plus 1, which is 4/8 plus 4, which is 12. Sometimes I see my students make this mistake, but it's not correct. And the reason it's not correct is because we don't have, our shape isn't split into 12s. The first shape is split into 8s. The second shape is split into quarters, into 4 different parts. Neither of these shapes are split into 12. So we know something's not quite right there. Now, what we want to be able to add these, as we had in the previous 2 examples, is to have our rectangles divided in the same number of squares. So in the first example, they were both quarters. In the second example, they were both 8s. Now here we've got one shape in 8s and one shape in quarters, and we need to do something about this. So what we can actually do, we're going to leave 3/8 the same. That's still 3/8. But I can split the 1/4 into 2/8 just by putting an extra line down the middle. That 1/4, if we go back to our equivalent fractions, that 1/4 is equivalent to 2/8. So that second one is now 2/8, and that's an important step because now the denominator of both fractions is 8. Therefore, I can add in the same way that I've added the previous examples. Because the denominator is 8, I know the denominator of my answer is also going to be 8. So I'm splitting this third shape, my answer, into 8 different parts. I've got 3 blue from the first one and 2 yellow from the second one. So those 3 8s plus 2 extra 8s is going to give us 5 8s. That is our answer. We get 5 8s. Now, some of you may have seen this step without the shapes before, the changing of 1/4 into 2 8s, but you might not have been sure why we've done it. As I hope this example demonstrates, all we're doing is we're just splitting the same amount. We've got the same amount shaded in, we've just split it into smaller parts. That's all we're doing. And if you're to do this without the diagrams, because sometimes we don't always have the time to draw in the diagrams if you're doing lots of different questions, sometimes we can just do it numerically. So if you noticed, when I divided my shape, when I put in that extra line, I divided the shape in half again. So I've divided it by 2. Now there are 8 parts. That's the same as multiplying both the numerator, which is the top of the fraction, by 2, and the denominator by 2. Whatever I do to one, I do to the other. The reason why that's the case is because when I put in that extra line, I made 8 squares, and the 1/4 I already had also got split in half, so that became 2 squares. So that's why we multiplied by 2. Now let's look at another one that's trickier still. So I've got my first shape. I'm going to split into 3 and shade in 2 parts. That's equivalent to 2/3. 2 out of 3 are shaded in. With my second one, I'm only going to shade in 1/4 again. So there are 4 possible ones, and in blue I've shaded in 1. Okay, so what we need to be able to add them is a common denominator. In this case, I can use 12 as a common denominator because both 3 and 4, both of these shapes can be split into 12 equal parts without changing anything. I couldn't split them both into 5s. I couldn't split them both into 8s, but I can split them both into 12s. To do that, for the first one, the yellow one, I've put in some extra lines, and now we can see there are 12 little rectangles in this shape, and 8 of them are shaded in. That's because 2/3 is equivalent to 8/12. Okay, for the second one, if I want to split that into 12s, I also need to put in some extra lines, okay? With these extra lines, this shape is now also split into 12s. And notice that when I put in those extra lines, the 1/4 became 3/12. That's because 1/4 is equivalent to 3/12. So now I have 8/12 on the left-hand side and 3/12 on the right-hand side. I can now add those two fractions because they have a common denominator. So I know my answer is going to also be split into 12s. So I'm going to put in those 12 lines to start with. I'm going to shade in 8 of them from the yellow part and 3 of them from the blue part. So 8/12, the yellow ones, plus 3/12, the blue ones, is equal to 11/12. And that's my answer, 11/12. I was able to add them because the denominator was the same. If we're looking at it numerically, to get from 2/3 to 8/12, I split it again into 4 parts. So I've multiplied both the top and the bottom by 4. For the second fraction, 1/4, I split into 3 parts again. So that's the same as multiplying by 3. That's become 3/12. So I've converted the two fractions so they have a common denominator, in this case a common denominator of 12. I've shown you why this works visually with the boxes and the shapes, and I hope that makes a bit more sense. You don't have to draw the boxes and the shapes yourself, but I think maybe referring back to this video would be a helpful reminder of why we're doing that. When you're actually doing these, when you're actually adding fractions, you probably only need to draw in the arrows, and if you get really good at it, you don't even need to do that. But I think this is a useful starting point if you're really confused about what's going on when we add fractions. I hope this has been helpful. If you have any other topics you'd like me to cover, please leave a comment and let me know. Thanks, guys.